from camera. So we had a circle with a chord length 48 and a distance from the center 10, so we could put that 90-degree symbol on it. Since we have the 90-degree symbol on it, that means that this radius or line that goes to the center would cut this in half. So we had 24 and 24, which means I have a right triangle that's 10, 24, blank. Well, this blank right here that I drew this radius in would be my hypotenuse of my triangle. So that'd make it a 10, 24, 26. We would have a 26 centimeter triangle. You could also use the 5, 12, 13 would have helped you get that as well. So I used the Pythagorean, I used Pythagorean triples to actually get it. I noticed that 10 divided by 2 is 5, then 12, 13 would be my other one, so 13 times 2 gave me that 26. So that was my Pythagorean triples. Hands up.
You know both of those lines are 24, right? From like angle side if you drew a triangle.
From angle. I know they're 24 because of this little guy right here, this right angle symbol. Any line from the center that is perpendicular to a chord always cuts it in half. So that's how I know they're both 24, is because of this 90-degree symbol here. We do have a theorem that says that. It's the one that basically says that a line that's center is a perpendicular bisector of a chord. It's the one that I put like the additional comment on.
Oh, yeah.
Yep. That's why I put the additional, because it's important. It's important to know it. A lot of people just kind of guess at it, but it's more important to know it, right? Why we could do that. So it's a great question. Other questions on the bell work? We are just going to plow through the homework, and then we'll go over homework questions, because I do know some people have some pretty in-depth questions, and other people do not, and this lesson is going to go really quick. So we're going to go through the lesson first, and then we'll go to homework questions. If I forget, let me know that I forgot. All right, so the first thing we're talking about is inscribed angles. We already talked about inscribed angles. Inscribed angles. In fact, nothing we're going to learn today. We're not actually learning that much new stuff. We're applying to different situations, and we're reevaluating what it means. So in that first sentence, it says, if an angle is inscribed in a circle, then the measure of the angle is equal to what? Is equal to what compared to the arc?
Half.
It's half. Perfect. We already covered that. This is half the measure of its intercepted arc. So let's look at that picture. We have an intercepted arc of 106 degrees. What is the value of A then? What is the value of A if that's 106 degrees? Leanne, it'd be 53. This would be 53. And that is because to go from that arc to an inscribed angle, you're just going to go 1/2, whatever that measure is. So it's 1/2 of 106 will get you your 53. So inscribed angles, you're thinking half. If you go the other direction, you just multiply by 2, right? If this was 53, I multiply by 2, I get to my 106. It goes both directions. All right, same thought process, but different setup. This one is, if two inscribed angles of a circle intercept the same arc, then the angles are. Who wants to take a guess at that? So I have an inscribed angle here. I have an inscribed angle here, and they said this one's 27. Who wants to take a guess at what that one is? Ishana. Not just corresponding. I think you're looking for a different word. Let's just go with, if this is 27, what does B equal? It'd be 27. They're congruent. They're going to be congruent. I knew what you meant. We just needed to pick the right word. Okay, so those are both going to be congruent. So if two inscribed angles of a circle intercept the same arc, then the angles are, in fact, congruent. Is this something you have to have memorized? Maybe not, because you could figure this out. Let's actually do it by hand rather than Sam.
So that would also mean that like the two top ones would be equal to, right?
The two top ones would also be equal. Yep. You're looking at this one and this one, right? Yep, those two would be equal as well. But let's look at that 27. Let's say I forgot this rule. I'm on the test, and they're like, find B. I'm like, uh-oh. there's some rule with that. We can actually solve it because if this is 27, what's the arc at subtends going to be? So let me highlight that interior angle that I'm talking about. I'm talking about that interior angle. So what is this arc's in degrees? What is the measure of that arc in degrees? Isabella?
64.
It would be 54. There we go. So if that's 54, what is B going to be? Half of 54 is going to be 27, right? So I did it the hard way. The easy way would just be, okay, they're intercepting the same arc. They're both 27. Gentlemen, let's make sure we're not talking while I'm teaching, please. Thank you. All right, so this lets me jump from here to here. Is it that hard to go from here to here to here? Not really. So if you forget this on the test, not the end of the world. You just have to do that extra step. It is nice to be able to see it so you can just put numbers down. Especially like Sam's like, oh, I can also see these inscribed angles too, because maybe I'd have a number here and a number here. Then you would know them all right off the bat versus having to figure them out. All right, cool. So that is if you have two inscribed angles. Our next one is an angle inscribed in a semicircle. Look at that inscribed angle. What is the measure of that inscribed angle? And if you're like, there's no way I could figure that out, you actually know this value. Yeah, what do you got?
90.
It is 90 degrees. It is, in fact, 90 degrees. Let's talk about how we got that 90 degrees. So let's put this down first, and it says an angle inscribed in a semicircle is a right angle. But this is another time where you didn't have to have this memorized. You could be on the test and go, okay, it's a diameter. Diameter cuts a circle in half. So that'd make this measure 180 degrees. Half of 180 degrees is 90 degrees. This is figure outable. This isn't stuff you have to have memorized. This is stuff you could figure out right on the spot. So you could be like, okay, this is 180 degrees. To get to my inscribed angle, you have to have half of 180, which equals 90 degrees. So either you memorize this, and you're like, okay, goes to the diameter, it's an inscribed angle, it's 90 degrees. Or you're like, I can figure it out. All right, this isn't stuff you have to have memorized, but it can be a nice shortcut on a test. And for a lot of us, time is of the essence on a test, right? These little kind of cheats can cut away seconds, turn into minutes, turns into, oh, good, I'm done on time. All right. So that's nothing new. Nothing new so far. This one looks new. Well, let's use some clues about this lesson to come up with a theorem for this. So it says the angle formed by a chord and a tangent line. So let's look at this drawing. We have a chord here. And it is important that this line is tangent for this to work. So we have a chord and a tangent line. They're intersecting on a circle. What is that compared to the arc it subtends? Who wants to make a guess at that? So that angle is formed. What is that compared to the arc it subtends? Now, you're not going to know this offhand, but you can use a little bit of clues from this lesson to help you. If this is in the inscribed angle one, it probably has similar rules. Hamza?
Maybe half.
It is exactly half. That is perfect. It is in this lesson because this, in fact, follows the same rules as an inscribed angle, where it's going to be half the measure of the arc. I'm going to erase this because it's really tiny. It's still 196. It's so tiny I didn't want to. So if the arc it subtends, remember your arc it's subtending is this full arc here, then the angle it cuts is going to be half that. Now, I want to be clear on that arc, or that angle. That angle is this entire angle. It's not like the little from the circle to here. It is your entire angle. It's like the circle is gone. That's going to be half of your 1 96. What's half of 196? Yeah, 98. So this is going to be 98 degrees. This one is something you have to know. This is one that you have to have memorized. This is one you're going to have to be able to pick out of a drawing because these are going to sneak up on you. It looks easy now, but you know a fact. When you have like a whole drawing with a whole bunch of them, you forget about it. A tangent line that connects with a chord is going to be half the measure of the arc it subtends. Hamza?
Yeah, do you know why that is?
We do. It basically has the same properties of an inscribed angle, just because it is tangent. If it was any other line, it wouldn't follow the same thing. So, and in fact, this is an inscribed angle. It kind of fits all the requirements of an inscribed angle, even though it doesn't quite look like it. It's an angle that goes to the back of a triangle, and this line is fixed. So it is, in fact, an inscribed angle. All right, so that is half the measure of the intercepted arc. Be careful, this line has to be tangent. It can't just be a line that cuts through like this. This has to be tangent. That is the most mistakes I see with this one. They'll just say any line that cuts through is fine. It has to be a tangent line for this property to work. All right, continuing on. This is another one we can kind of make a guess at. Arcs formed by parallel chords are, in fact, what? So if this is 78, who wants to take a guess at what D equals? Carly?
78.
They're congruent. Perfect. So arcs formed by parallel chords are, in fact, congruent. So if one side of a parallel line is 78, cuts an arc that's 78, then the D is going to equal 78 degrees as well. They're going to be congruent to each other. All right, we got one more. This is also one that we can take a shot at. If a quadrilateral is inscribed in a circle, then its opposite angles are what? So G and F are what? Arya?
Supplementary.
Yes, in fact, they are supplementary. So that means if F is, let's say, 81 degrees, what's the measure of G? If F is 81 degrees, what's the measure of G? Hamza, thank you.
99.
It'd be 99 degrees. Yep. G would be 99 degrees. And that would come from the fact that you just do 180 minus 81 degrees. Yeah, Cam. I made it up. Yeah, there was nothing fixed on there. I didn't read it or anything. We don't know what size it is. In fact, that probably looks a little smaller than 81 degrees. I made it up. I just didn't put any values on there. So in fact, Cam, this is what I was doing. I was just saying if F equals 81, then we solve for G. That's it, though. Any questions on any of the stuff we just covered? Cool. Then if you don't have any questions, you can work, listen to the next part, quietly on the homework. That means no whispering, no going, pss, 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 did you get this? Pss, pss. No talking until I'm done going over questions from the homework because I don't want it to be a distraction. People have serious questions on this. There are some complicated problems. I want to be able to go through it without being distracted, all right? So until that point, you can work quietly. If you get stuck and you need help, just move on to a different problem, and then I'll be more than happy to help you after that. All right, that being said, what questions do we have from the homework? Hamza.
So number 10, I did I used sine.
Cool.
Sine of 60 degrees equals x over 24.
Awesome. Yep, that'll be fine. Brendan. Number 13. Number 13 is we have that drawing, right? Let's see if I can draw it really quick. So we have that big circle. We have this little circle. Then we had a line connecting our centers. That looks pretty good. This was A. This was C. Then we had a line that connected here. We had a line that connected here. And then we had a line connecting There. Oh, that was like my best drawing ever. Anyone want to take a picture of that? No. Tori, you're supposed to at least pretend, like, we don't even have phones on us. How are we supposed to take a picture, right?
That's very true.
That's not just, no, who would ever want to picture that, Mr. Pavey? It's beautiful. It's art. All right. Then we read it. It says that AB equals 36. So let's go ahead and, I'm sorry, was that, yeah, AB equals 36. So this distance here is 36. Then it says that CD is 24. Let's go ahead and mark that. And then it says the distance from B to D is 80. I'm going to do my patented, I'm going to draw it kind of above it. That distance is 80, just so it doesn't get all muddled. All right, that's all information we're given. Well, we actually know a lot more than that. We know that a line that goes from the center to a tangent line is going to be 90 degrees. So we actually know that this angle ABE is 90 degrees. And we also know this EDC is 90 degrees. Well, since this line and this line are both 90 degrees compared to each other, they're going to be parallel to each other. So AB is actually going to be parallel to CD. Well, that means that angle A and C are alternate interior angles. You did not need to know that. You could have also used vertical angles as well, right? So let's go vertical angles just in case I didn't see it, because alternate interior angles are sometimes buried. Let's just look at the vertical angles here. Well, that means this angle is the same as this angle. This angle is the same as this angle. So this triangle right here must be similar to this triangle by angle. Angle lets you say that two things are similar to each other. So that means they're similar to each other, so their shapes have a ratio. They have a ratio between the two. So if we're looking at this big triangle and little triangle, they have a ratio between the two. And that ratio is going to be corresponding side over corresponding side. So I'm going to do CD over AB, which would be 24 over 36. I didn't make any mistakes, did I? I want to make sure I have all the numbers right. Yes. All right, so that's just going to be 2 over 3. Well, now, the whole problem is I'm supposed to find A to E. I'm supposed to find this distance here. Well, if we notice we have this long 80 right here. I want to talk about that in terms of the two triangles. So what I'm going to do is I'm going to label one of the triangles x length, and I'm going to label one 80 minus x. So let's go ahead and call this distance from B to E x. And then from E to D, let's call that 80 minus x. Well, this is the ratio between our two triangles. It's 2 to 3. That is small triangle over big triangle. So what we're going to do is we're going to do small triangle over big triangle, which would be 80 over x, or 80 minus x over x equals our ratio of small over big. That's going to allow us to solve for x. And I'm going to let you do that using cross multiplication, but you should come up with x equals 48. All right, if x equals 48, that means we now know this side of a triangle, this side of a triangle, and we're supposed to find the hypotenuse. So that's just going to be 36 squared plus 48 squared equals c squared. A squared plus b squared equals c squared. And that will get you your AE. Do you think that's far enough? Yeah, good? All right. Hamza, did you have a question in there?
I think I forgot it.
Okay.
Yeah. Can you explain again why AB and BC are parallel?
Because they're both right angles. We had a theorem that said if two lines are conjoined by a line that is 90 degrees and 90 degrees, they have to be parallel to each other.
Okay. Was that this unit?
It was not. It was a while ago. But if you think about this, so if I'm standing straight up right? And the ceiling's 90 degrees to me. My ceiling and floor are parallel to each other. That's in essence what's happening. They're locked in to be parallel. Because if you're fixed at 90. All right, other questions? Hamza.
For number 16, for PQ, I got 90 because I used A squared plus B squared. Or for PQ, I got 19.
For which one, I'm sorry?
For number 16.
Okay.
I got PQ is 19 because I did A squared plus B squared plus C squared.
Let me take a picture and let's see what numbers we had similar and different. So PQ, you got what?
19.
You got 19 for it. What'd you do different than me, I guess?
So let me see.
It shouldn't have been 9 because you should have gotten QR first, right?
Yeah, I got QR first, and then I got 2 radical 30 because I did A squared plus B squared equals C squared.
So did I. So I did A squared. So we had this small triangle here. We had 6, 8. You should have gotten, for QR, you should have gotten 10.
Oh, I see what I did. I did 8 squared.
Oh, okay, yeah. Other questions from the homework? Yeah. No, it's a cool problem. It's a really cool problem. If you got it, awesome. Awesome. If you'd like to see it, I'm more than happy to show it, but you're like, no. Other questions from the homework? All right, then. The rest of the time will be for you to work, so you can start talking, and I'll come around and I'll help you on any homework questions you guys have. I guess I'm going to this.